All right, hi guys. We are looking at another way to find the length of our segments, which is called segment addition. So let's jump right in here. We are looking at the segment addition postulate, which specifically says if a point is between two endpoints of a segment, then the sum of those two parts of that segment are going to be equal to the whole entire length. So what we want to get out of this is that the word between in geometry does not necessarily mean it's in the middle. Between just means it's somewhere along that segment, might be in the middle, it might be closer to one end or the other, but that nether point is somewhere along that segment. So we have a specific formula that we're going to use to set up this equation. So we're looking at part 1, which will be the first segment, plus part 2, the other piece of that segment. Add those together to give us the whole entire length. So let's see where our parts are going to come from in a segment. All right, so we have our segment here, and it's actually 3 separate segments. We have segment AB, which is going to make up part 1. We have segment BC, which will make up part 2. And if I add those together, that's where we're going to get the whole entire length. So right now we have AB plus B to C will give us the whole thing. So hopefully that AB plus BC looks similar to what you saw on a previous assignment. So now our whole entire thing, beginning to end, that makes up your whole length. In this case, that's A to C. So AB plus BC should equal up in total to the length of AC. So let's try this out with a couple examples here. All right, so we're looking at example 1. So we need to find our parts. All right, so we've got, oops, sorry, it's a little too big. All right, so example 1, find EF, or the length of E to F. So right now, E to D, my part 1. D to F, my part 2. So our formula says part 1 ED plus part 2 DF to get the whole length, which is EF. Let's put in our numbers. 1.2 plus 1.9 to give us 3.1. So the length of EF, 3.1. All right, let's see and try an example 2. All right, example 2, find BC. So this time we're looking for this piece. So notice where this 13 is. It's all the way across. So guys, this is our whole length. We have part 1. We're looking for part 2. So let's write out our problem here. All right, part 1, AB, plus part 2, BC, is equal to the whole thing. In this case, that's AC. So let's plug in what we know. AB 5 plus BC is my question mark. I don't know it. And AC, the whole thing, 13. So I'm going to solve this like I would if it was an algebra problem. I'm going to minus that 5, minus out what I do know from both sides. And so my missing BC piece has to be 13. Take away that 5, which leaves me with an 8. So there's my missing part. So let's step it up a little bit and start introducing some algebra to this because I know we love it so much. All right, so this time find X and AC. So let's write up our starting problem here. All right, so I need part 1 plus part 2 to get the whole length. So let's fill in our pieces. Part 1, A to B. Part 2, B to C. So part 1, part 2, all the way across my whole length, AC. So now let's fill in these pieces. All right, so part 1 is an X. Part 2 is a 2X. My whole length, 2X plus 5. So now we can solve this equation. All right, so I have an X and a 2X. So I have 3 X's is equal to 2X plus 5. So now we can keep solving this. Now with these kinds of problems, and you're going to see more like these that have an X on both sides, I recommend you always start with the smaller X. So 2X is smaller than 3X. I'm going to cancel it out first. So minus my 2X to both sides. So on the right, they're going to cancel. And 5 is equal to 3X minus 1 minus 2X. Just leaves me with 1X. So there's the first part. There's my X. Now we need to find AC. So let's plug it back in. AC is supposed to be 2X plus 5. Now we know what X is. So that's supposed to be 2 times 5 plus 5. So my AC should be 2 times 5 is 10 plus another 5, 15. And there's my final. All right, let's try another example here. All right, so example 4, find the value of X and RS if S is between R and T. And then it tells us how much goes to each piece. So notice this one doesn't have a picture, so we need to draw it out. All right, so if S is between, that means my R and T are my endpoints. So let's get these on here. R and T, S is somewhere in between there. Now let's fill in everything else we know. R to S, 6X, S to T, 12, and the whole entire thing, 72. So let's set up our equation and let's solve this out. All right, so part 1, 6X, plus part 2, the 12, equals the whole entire way across, 72. So now we have an equation, we can solve it out. So let's subtract this 12 from both sides. My 6X is equal to a 60. Divide out your 6. And my X is 10. So there's the first part. Now we needed to find the length of RS. So let's plug that in. So RS is supposed to be a 6X. Well, X is now a 10. So RS is 6 times that 10 for 60. And there's our missing part. All right. So let's keep going now. Let's see if we can step it up just a little bit more. And let's check out example 5 here down at the bottom. All right, so example 5 says point F is between G and H. So let's make that segment real quick. Well, that's not very pretty. Let's zoom in here, make this a little bit easier on myself. All right, point F is somewhere between G and H. All right, let's fill in everything else we know. All right, GF is 3X plus 9. So let's get that in. 3X plus 9. Okay. FH, 5X minus 2. All right, and then we know GH, which is the whole entire way. Actually, I'll put this on the top. So bear with me for just a second, guys. I'm going to move this down. Okay, so GH all the way across 11X plus 4. All right, so same situation as before. We want to add up our two parts. and then set them equal to the whole, and then solve it out. All right, so our part 1, GF plus part 2, FH, is equal to the entire way across, all the way from G to H. Let's plug in what we know. 3x plus 9 for the first part, plus 5x minus 2 for the second part, whole way across, 11x plus 4. That does not look like a plus. There we go. All right, so now we've got some combining of like terms we can do. I can bring together my 3x and 5x to give me a total of 8x. I've also got a 9 and, sorry, make this a little smaller, a plus 9 and a minus 2 for a plus 7, which should equal 11x plus 4. So let's keep solving. So again, I said when you have letters on both sides, start with the smaller letter. My 8x is smaller than 11x, so I'm going to cancel it first. Minus 8x, minus 8x. So 7 is equal to 3x plus 4. Let's keep going. I'm actually going to move this over here to the top. So if 7 is equal to 3x plus 4, now I can minus that 4 to both sides. 3x is equal to 3. Divide both sides by that 3, and I have a 1 for x. So there's the first part of my answer. Now I can start plugging this back in and find the length of all those missing pieces. So let's see what we need. So the first one we need is GF, which is 3 times what we got. So 3x plus 9. Let's plug in our 1. And then add 9 to that. So 3 times 1 is 3, plus 9, a 12. So GF is equal to 12. Let's find the next piece, FH. FH is supposed to be 5x minus 2. So 5 times 1, take away 2. So 5 times 1 is 1. I'm sorry, 5 times 1 is 5. Take away 2, and we get a 3. And then our last piece, GH, is 11x plus 4. Substitute in that 1. And GH should be 15. Now, notice if we were to add these up, the 12 and the 3 are supposed to make a total of 15, and sure enough, they do. Because again, 12 plus 3, part 1 plus part 2 should make the whole thing, which is 15. All right, so from your segment addition, we also get another postulate, which deals with congruence. Now, congruence is more than just saying things are equal. Specifically, congruence means we're looking at the same, exact same size and shape. Congruence is kind of like talking about identical twins. Now, we also have a symbol that we use for congruent, which is called a tilde or a squiggle on top of an equal. But that's our symbol. And anytime we talk about two things being congruent, we're going to use that symbol. And we use that symbol a lot. So let's talk about how segments can be congruent. What do we look for? Well, when it comes to the figures and the pictures, we need to find matching numbers of dashes. So matching dashes, meaning they need to match in how many there are. So 1 dash each. Look for ones with 2 dashes each or 3 dashes each. They need to match. So if I'm looking at this first segment, if B is going to be the middle, making two congruent segments, then either side of B would have one dash. So again, those are our congruent marks. Our little dash here and our little dash there, they match. One dash and one dash, so A to B is going to be congruent to B to C. Now, that also makes something very special about point B if it does have congruence marks on either side of it. We call that a midpoint. Okay, we call that a midpoint, which is also known as, definition for that, the point in the middle. Hence, mid for middle and point. So for this situation, we would say segment AB is congruent to segment BC. And that's how that statement would be read. That's how we would write that out to say that those two segments, the right one and the left one, are congruent. Now, not always are the segments that you're going to deal with going to be connected. Just like the second picture I've got over here, segment WY and segment XZ, they are not connected. And there's nothing wrong with that. But we can still say that they are congruent as long as they have matching dashes. Two dashes and two dashes. Even if there was a third one up there that had two dashes, then all three would be congruent. So right now we have segment WY is congruent to segment XZ. And if we know that those two pieces are congruent, then more specifically, that tells me their lengths are identical. So again, notice this time there is no squiggle on top of that equal, and there are no symbols on top of those letters. Because again, the top one is reading the two things are congruent. The bottom one is reading their lengths are the same. So let's use that idea and make another formula that we're going to be using. So when we have a midpoint, or when we have congruent segments, this time we're not adding anything up. If we're looking at congruence, this time the two parts are equal. So let's use that and see if we can work through some problems here. Now, not always is it necessarily going to be a point that is at the cut making a congruent part. Anything that is making two congruent parts like that and passing through a middle is called a segment bisector. So specifically, it is an object that cuts a segment in half, making two equal parts. Okay, that's our big thing here, making two equal parts. So using that, let's do our last two examples here dealing with midpoint. All right, so find the length of X to Y. All right, so notice again, X to Y. We're looking at X specifically. Look what's on either side of it. Two dashes and two dashes, meaning that X is a midpoint or a segment bisector. So if I have a midpoint, I have part one is equal to part two. So let's fill that in. I'm going to come over to the side here. So part one equal part two. Let's fill in what we know. Part one made up of WX. Part two, XY. And let's plug in. Now, here's the thing. All we know is all the way across is 6. And like we talked about on the previous assignment, if we know that there is a point halfway sitting in the middle, I can cut that in half. So if I know my whole length, then I can cut that into two parts because again, XY and WX are supposed to be the same. So let's do that and see what we get. So if the whole thing is supposed to be a 6, I'm going to divide that into two equal parts, which means my WX is a 3, and so is xy. And 3 is what I needed for xy. All right, let's look at our last example, example 7. Now this time again, find x if b is a midpoint. So again, they're telling us if that's in the middle, part 1 and part 2 should be equal. So let's use that to set this up so we can solve. Part 1 equal to part 2. So part 1 is a to b. Part 2 is b to c. Let's plug these in. AB is 2x minus 8. B to c, x plus 17. Now we have an equation we can solve. All right, so just like earlier, you have two letters, you have letters on both sides. You have a 2x and a 1x. So I tell people cancel out the smaller variable first, which is your 1x. So minus that 1x from both sides. So x minus 8 is equal to 17. Add your 8 back. So my x is equal to 25. If we needed to find the different pieces, then I could plug that back in. But this question just wanted to know, find the value of x. So guys, I hope you enjoyed learning a little bit about segment addition. We will use these same ideas when we start getting into the later parts of this chapter. So make sure you keep up with this video. And guys, I hope you have a great rest of your day. Bye.